All right, so we want to look at the tangential acceleration now. The tangential acceleration is just the acceleration perpendicular to your path. That is how fast you're going, right? So the tangential acceleration changes your speed. Okay, so you're moving along this circular path, but your speed is still changing. And this is actually not much different from your usual definition of acceleration, right? Usually when you talk about your acceleration, you're going around in a circle or you're going in a straight line, right? And you might be going 5 meters per second here, and you're slowing down, so you're going 3 meters per second here. And if this is uniform, over here you'd be 1 meter per second, same time intervals. Same thing's happening here. Over here you might be at 5 meters per second, at whatever this radius is. And over here you might be at 3 meters per second. And so your tangential acceleration is perpendicular to this. It's perpendicular to your curve or your circle. It's tangential to your circle. That's why it's called tangential. AT. And it's the same AT over here as over here if it's uniform, which is probably what we'll stick with. So that AT is just slowing you down just like your acceleration over here is slowing you down. Right? And so that's all that's happening. So that means our tangential acceleration, AT, has the same definition. It's just change in speed over time, which means it's v2 minus v1 over t2 minus t1, right? So this is the time where we start. This is the time where we end. So we're measuring over a particular time interval, like t1, t2. And then we have our velocities. This is our final speed. I guess these are speeds, not velocities. Excuse me. This is your initial speed. This is your tangential acceleration. All right, so we end up with more or less the same thing that we had in one dimension. We're just moving from this T2, or from this V1 to this V2, and we subtract here, and we have, this is T1 and T2, rather than being along a line. So this is more or less what you're familiar with one-dimensional motion. This is just what's speeding you up or slowing you down, whatever is causing this acceleration. Okay. Next I'll do an example, probably the more intricate of the examples we'll look at. And then we'll go back and talk about putting the tangential and the radial accelerations back together. Bye now.